Welcome to Win 301, Security Best Practices for Running Microsoft Technology and Products on AWS. I'm Bill Jacoby, Principal Solutions Architect, and my co-presenter in this session is Sean Asfeld, who's a Senior Solutions Architect. What we'll be talking about today are the 5 topics that you see here. We'll be focused on overall security on AWS, how to build security-hardened Windows images, securing AWS Directory Service, administering Windows EC2 instances securely, and going beyond security and deploying applications to meet compliance programs like FedRAMP High and other industry compliance programs. So let's jump straight in. We'll start with security on AWS. So traditionally on premises, you as the customer are responsible for everything you see on the slide here. You're responsible for end-to-end security, starting from hardware on the bottom of my slide, compute, networking, storage, software, any encryption that you use, configuring operating systems, firewalls, routers, switches, as well as configuring your individual applications and identity and access management, including Active Directory. And layered on top of all that, you're responsible for securing your customer data. And so really, on premises, you're responsible for all of these areas. In the cloud, we have a shared responsibility model in which we as Amazon take care of what we call security of the cloud. And what I mean by that is we protect the infrastructure in the bottom half of that previous slide. We protect the compute, the storage, the networking, the facilities. We protect and secure all of that. We also build in security services into all of the AWS services that we offer up to customers. And so we talk about a shared responsibility in which, while you don't need to take care of security of the cloud, you do need to take care of security in the cloud, by which I mean you would be responsible for securing the services that you choose to deploy. So for example, if you choose to deploy Amazon Simple Storage Service, it would be up to you to additionally configure, for example, server-side encryption, or for example, to configure signature v4 in all requests that are made to Amazon S3. And so while we provide security of the cloud, it's the responsibility of you to provide security in the cloud and to configure the security capabilities that we make available, for example, in EC2, VPC, Amazon S3, and other AWS services. And so that's the overall model. And within the Amazon cloud, there are lots of security services. And this is not a session specifically on security in AWS overall. It's really a session on how to secure Windows instances in the AWS cloud. And so this slide covers a lot of our services, the services that we categorize as security, identity, and compliance services. And we'll touch on a lot of these. We won't necessarily be doing deep dives into the services, but the services that you see here in gray are the services that we will be talking about and that relate to Windows. They also relate to Linux, but we'll be using Windows examples throughout this presentation. Okay, so let's jump into really the first security topic, which is building security-hardened Windows instances or Windows images. And so I'll start off the same way I did just a second ago. How do you build golden images today? Well, today, customers typically will go through a manual process in which they will build an individual server image. They'll add software to that image. They may add, they may use Jenkins or other tools to automate how they're adding configuration settings to that image. And you typically will build and maintain your own custom automation, whether it's using Jenkins or another package. And there's lots of open source packages that are available for managing images, but it's a very manual process today. And we have lots of customers who are saying, we want all of our Windows images to meet a baseline secure level. And we want to make sure that every time there's a new security patch from Microsoft, that patch gets added to those images quickly and efficiently, and nobody in the organization needs to worry about, do they have the latest security baseline? And so customers have asked us for a one-stop shop to build these golden images, to avoid some of the manual steps and quickly and easily build automation to create golden images without necessarily having to write a lot of code. Customers have also said, well, we'd like to make it easy before we release these golden images to have them tested with automated tests so that we know the image is secure, as well as has the applications that are required for the organization. Customers want to be able to secure images with Amazon provided and with custom settings that meet both your internal standards, but also industry standards and potentially industry compliance programs. So we'll talk how to do that. And customers also say, okay, well, once we have a golden image, we'd like to distribute and share it. We'd like to distribute it across all the accounts that are operating in a single region. We'd like to distribute those golden images across all AWS regions so that everybody is using the golden images, and it's easy to consume golden images once they're created on a monthly or other cadence. We also, by the way, get the request all the time to be able to use a solution, an automation solution from Amazon, to be able to build golden images that can be deployed on premises. And so we see these 6 areas here as really the requirements for building golden images. And we have a solution for doing that. We have a service called EC2 Image Builder, which helps you build and maintain secure images, including Windows images. Okay, so how does Image Builder work? Image Builder allows you to basically create an automated pipeline to keep images secure and up to date. If you use an automated pipeline, you can essentially minimize exposure to security vulnerabilities. And the goal is to be able to validate and deploy high-quality images into production in your site. And we'd like to make it possible to support both AWS and on-premises images. And we'd also like to really simplify the sharing of images across accounts. And so the slide that you see here is really the pipeline that Image Builder supports. And this basic pattern that you see here of starting with a source image, by that I mean an Amazon machine image, an AMI. By starting with a source image that has as many of the settings as possible to begin, then our Image Builder service gives you the ability to customize that image with software configurations of your own, to secure the image with hardening to, for example, a CIS standard or a STIG standard or your own internal standards. EC2 Image Builder gives you the ability to test the image before it's released. For example, you've added a number of patches. Do the applications that are running on the image continue to operate? And a whole variety of tests. Do the images that you're deploying also enable you to, for example, interoperate and from a networking perspective, reach your other servers and hosts? And once this image has been built, customized, hardened, and tested, then we want to make it really easy in Image Builder for you to just make this an AMI that can be used in any region. And so these steps here, this pipeline that I've described, is how EC2 Image Builder works. We use the terminology of coming up with an image recipe. And a recipe consists of essentially the 3 steps that you see here: build, validate, and test. Build and validate is really all about taking the base image and installing software onto it, potentially installing applications onto it, making settings and configuring the image. And this includes the whole range of options that are within the OS, but also the range of options that are on the AWS platform. For example, on the AWS platform, you may want to design the image to work in one or more VPCs. You may want to design the image to have a number of security groups so that the instance is protected from network traffic that can access the instance. Only certain ports and protocols are allowed to the instance, and only certain ports and protocols are allowed from the instance. So the recipe is all about building the instance, configuring AWS security capabilities, but also configuring security capabilities within the OS itself. So this may be, in the case of Windows, registry settings, STIG baseline settings, group policy objects, and validation and really building and validating are very similar tasks because in both cases they typically mean running PowerShell scripts or using settings that we've made available in templates to harden an image that starts off as an AMI. And then testing your component, we have a number of tests that we include in Image Builder. Very basic tests from will an AMI result in an instance that will successfully boot, through to lots and lots of other tests. For example, you may be building a SharePoint image and you've installed 50 different prerequisites for SharePoint. Each prerequisite individually in the build validate stage was installed and returns a success code that, for example, SQL Server Client 11 was successfully installed. But until you've tested full SharePoint, you don't actually know if those 50 dependencies are really configured correctly. So build, validate, and test all together are the ways in which we help you create a recipe, and we give you a number of predefined recipes. And once you've created a recipe, then it becomes very easy to just continuously update and deploy secure images on a cadence. So for example, once you have an image, then every month we may have a new source AMI that has the latest patches from Microsoft Patch Tuesday. That will become the input, and you'll apply the same recipe to result in an output AMI that's fully secure. So that's essentially what Image Builder does. It supports this three-part build, validate, test methodology. And I've mentioned that this all happens in the context of a pipeline. So you start with the recipe, you apply the recipe to the source image, then you configure some of the things that I mentioned, like the subnet, the security groups. You may set up logging through CloudWatch, or you may set up logging through SIEM systems like Splunk or Sumo Logic. You'll identify a distribution pattern. So once we have an AMI that's been created, let's automatically distribute it to, for example, the US regions, or potentially the US regions plus a region in EMEA, whatever you would like. These can all be defined as part of the pipeline, and you can configure a schedule to have your golden images built either on a manual basis, a weekly basis, a monthly basis, and so forth. And all of that, and that pipeline enables the continuous creation of golden images on a schedule. Okay, so that's what Image Builder does, and let's actually take a look at it and see it in progress. Let's jump right in. We'll create an image pipeline. We have an option of creating it on a schedule using a cron expression when to run it, or running it manually. We will run our pipeline every week on Monday at midnight. And we'll create a new recipe. Had we created an existing recipe, we could choose it right now. Our recipe will be based on modifying an existing AMI. And the base image for our Windows AMI will, of course, be Windows. We could choose a whole variety of Linux distributions if we were creating an automated pipeline for building Linux images. And we'll start by picking Amazon managed AMIs. And so in this case, we'll pick Windows 2016 full. We'll leave those defaults the same, and we'll pick a couple new Windows components. let's create a STIG image, and we'll create a STIG medium image. And let's also create a CloudWatch agent and put that inside the image. And you can see that we have these two components, and I can shift around the order of these components. Secondly, let's build some tests to verify the output AMI. And so the basic test that we want to run is a reboot test to make sure that with these hardened settings that any instances built from the AMI will in fact reboot. And we'll keep the other settings at their defaults. In terms of infrastructure configuration, we'll keep all the defaults, meaning we'll use the default IAM instance profile and the default IAM role. And this any instances created from this AMI can be run in any VPC and any subnet, can use any key pair, etc. And our distribution settings we'll keep at the defaults so that we'll create AMIs that can be used in US East 2. Okay, and that's all it takes. Here's the review screen. That's all it takes to build an image pipeline. So we're now in the process of creating the pipeline, and the pipeline was created, the recipe was created, the infrastructure configuration was created, and the distribution settings were created. Okay, now because we set up our pipeline to run at midnight weekly, we do need to run this pipeline manually if we want to see the results of it right now. And so I could either click on this link or click on run the pipeline manually. So that's what we're doing here, and we'll pause while the build instance is created and the test instance is created. We can take a look at the build instance. And you can see that the build instance has been kicked off and is currently in a running state. So this will finish. This will add the two components that we created, and then this instance will be terminated, and then we'll create a test instance where we'll run the test components that we added. And if those succeed, then we'll create an AMI, and that AMI will be created on the schedule, the weekly schedule that we set up. Okay, and so our build instance completed and terminated. Our test instance was spun up, completed, and terminated. And let's go back to Image Builder. And we can see that the Windows AMI pipeline also completed. And if I click here, we have one AMI that's now available. And I can take a look, for example, in EC2 instances and also see that new AMI that was just built by EC2 Instance Builder. So that's the EC2 Image Builder service. So I hope you can see that we really simplify the complex task of building hardened images. And if you saw in my demonstration, we make it very easy, for example, to start off with baselines like CIS hardened images and STIG hardened images, and use those to configure the OS by basically selecting a template that we give you, and then you have a STIG high, a STIG medium, or a STIG low, or various versions of CIS hardened images, and anything else that you would like to apply to that image. And so that's EC2 Image Builder. There's other things you can do to create hardened images. So we also have a service called Systems Manager, and Systems Manager has a run command, and the run command can take as an argument any one of hundreds or thousands of documents that we provide as Amazon, or documents that you create. And by the way, when I use this term document, what they really are is PowerShell scripts. And so it turns out that within AWS Systems Manager, one of our PowerShell scripts is configure an OS for a STIG image. So what you're seeing on the screen here is the ability to run an SSM document for configuring a base OS for STIG medium or for STIG high. And so this would be an alternative to the EC2 image building process I showed you a second ago without the entire pipeline infrastructure behind it. So this is another mechanism for hardening images. And if you can see on the bottom here, this applies to not only Windows, all the versions of Windows Server you see here, by the way, including Windows Server 2022, but also versions of Linux, which you can see on the slide here as well. Okay, so, and the final option for choosing a hardened image is just to pick one that's already been pre-created in the AWS Marketplace. And so my example here is if you go to the EC2 service and you're put into the wizard to create an instance, step one is choosing an Amazon machine image. If I type in there that I want a STIG for Windows Server, you'll see that right from Marketplace will offer STIG images. You'll see a STIG image for Windows Server 2016 and Windows Server 2019, and that's a third mechanism for finding and deploying hardened images. So that's really how you would create hardened images. The next topic that we want to talk about is how do you secure Active Directory? And I don't think it's really a surprise to anybody in the Windows world that Active Directory has been the technology that has been subject to multiple attacks and exploits. And so I've listed a couple on the screen here: Zero Logon, Foggy Bottom, the Print Spooler exploits, Golden SAML. There are dozens and dozens of Active Directory exploits. And so the second topic really for this session is, well, how do you lock down and secure Active Directory? And so what I want to do is start off by mentioning that we have a managed Microsoft AD. We offer Active Directory as a service. And let me just say a couple words about what is our service and then how we can harden it. And so the first thing is that the AWS Managed Directory Service is based on Active Directory that ships in Windows Server. So we haven't sort of built our own Active Directory or tried to clone Microsoft Active Directory. We're using Active Directory that ships in Windows Server. Okay, and that's this little triangle here in the middle. Then when we deploy Active Directory, we deploy it in a multi-availability zone model such that domain controllers are deployed in pairs across AZs. And by the way, whatever domain name you determine, you pick, you can also deploy the same domain across regions. So if you're example.com, you're not just example.com in US East, but you're example.com in US West and in EU West and whatever region you want to deploy managed Active Directory. So the two I have here are meant to indicate two different availability zones within a region. Third, we provide automated matching of our managed domain controllers. And so what I mean by automated patching is just that as Patch Tuesday comes out, or if Microsoft releases out-of-band security releases, we will automate the patching of all domain controllers that are part of the AWS managed Microsoft AD service. We provide and enable automated logging and monitoring. So logging and monitoring, I'm pointing in my slide here to Amazon CloudWatch. There's really two types of logging that we do. There's the logging that Active Directory does, where security events are stored in the security log inside Event Viewer, and those logs can be forwarded directly to CloudWatch. But we also have security events or overall service events that take place in the Active Directory service, in the managed AD service. For example, the service was started, the service added a new domain controller, a domain controller was determined to be corrupted and was taken out of service, a domain controller was replaced, and so on and so forth. So there's a whole set of service security messages that we also create in the service, and we give you the ability to, which almost all of my customers take advantage of, to just enable, and we give you the ability to enable forwarding these security events to Amazon CloudWatch. So that by using CloudWatch, you have one place to go for all security events that are sourced from the operating system, from Event Viewer, out of the security log, and you also have all the security events and all the service events that are part of just the directory service. Lastly, the AWS Managed AD service is compliant with FedRAMP, PCI, HIPAA, SOC, and a number of other compliance programs. And so we'll be talking about some of those programs and the things that we've had to do to achieve those program accreditations. But you don't need to do anything special by simply running the managed Microsoft AD service. You inherit all the controls and you inherit the compliance for FedRAMP, HIPAA, and others. Okay, so this is essentially what is Microsoft managed, AWS managed Microsoft AD. And I should mention here at the end, number 6, that AWS Managed AD also integrates with the other things that you see on the screen here. So we integrate with our SSO service, our single sign-on service. We integrate with AWS applications like Workspaces, WorkDocs, AppStream, and so forth and so on. And we also integrate, our Managed AD service also integrates, for example, with EC2 applications like SharePoint or .NET or SQL Server, all of which can be domain joined. And you can domain join those applications to AWS Managed AD. You can also domain join, for example, the relational database service for SQL Server or the relational database service for Oracle. You can domain join these Amazon services to Active Directory, to Managed Active Directory as well. So that's really what is AWS Managed Active Directory. And there's a number of ways that you can harden AD for to be the most secure, to be the most secure possible. So the first thing is all the things that you would do typically in the on-premises world, you would still do in the cloud world. So it still is your responsibility to add users, add groups, set up GPO password policies, all of the things that you would do on premises that really relate to how you would administer AD, you would still perform these functions in the cloud. Okay, you would configure trust relationships with Managed AD. What I mean by that is, do you want to set up a one-way trust relationship with your on-premises AD so that Managed AD on AWS is a resource domain or a resource forest? Do you want to set up a two-way trust relationship? So how you think about trust and what you want to configure is entirely up to you. Configuring a certificate authority on the cloud is, again, up to you. And you can configure your own certificate authority on AWS. You can extend AD from on-premises to AWS and extend certificate authorities from on-premises to AWS. You can configure Managed AD. So I mentioned all these services a second ago. It's up to you to configure, for example, if you're deploying the relational database service for SQL Server, it's up to you to configure, configure domain joining for those SQL Server instances. And then lastly, it's up to you if you would like to configure LDAP-S, multi-factor authentication, private link, which I'll talk about in a second, and log forwarding. Okay, so these are the responsibilities that you would have on premises at a directory level are things that you would continue to configure for AWS. We don't force you into, certain predefined groups or GPOs that you can't change, or trust relationships that are fixed and you've got to use the way we define them. All of these are things that you configure when you're deploying Managed AD in AWS. Okay, so I want to talk about a couple specific things. I mentioned LDAP-S. And enabling LDAP-S is a great security capability of Active Directory. by default, Active Directory does not support having LDAP-S enabled. So LDAP-S can be enabled, and when you do that, then any calls to the directory, looking up a user, looking up a user's ACLs, all those kinds of operations take place over LDAP, over SSL TLS. And so within Managed AD on AWS, you can, and we encourage you to enable LDAP-S on the server and at the same time, LDAP-S on the client. Okay, next, we provide a lot of built-in GPOs. And so I have 2 slides that highlight the GPOs that we provide. So if you look at Area 1, we provide a GPO called AWS Managed AD Policy. And this is in this GPO object that you see over here on the right. And what that does is that policy contains the settings for FedRAMP, HIPAA, PCI, and we use this GPO to turn on the settings and enable the controls that give us that security posture. Within this GPO, we also give you the ability to set up your own fine-grained password policy. So for example, you can identify a minimum number of passwords that have to be unique before a user can go back and say, well, I want to use the password I used 2 years ago. What is the minimum length of a password? What is the minimum time duration or minimum age of a password? What is the maximum age of a password? What are the complexity rules that you'd like to employ? So many uppercase letters, lowercase letters, numeric symbols, et cetera, et cetera. You can also, so we give you this ability to customize basically these settings in the AWS Managed Active Directory policy. We also provide the DDCP policy that Microsoft provides by default. So the default domain controller policy, which ships with Active Directory, we use the defaults that come from Microsoft. And we do provide a default domain policy, a DDP GPO, and we use the defaults that Microsoft provides in the box. We've added one additional setting, which is that we force the user to be logged off when logon hours expire. So the DDP GPO is identical to what Microsoft provides in the box, with the addition of if a user is logged on when logon hours expire, we will automatically force a user log off. Okay, now we have three more GPOs here. We have a GPO for the AWS Reserve Policy user, number 4 here on the screen, and that lets us allow users to use screensavers. If a user uses a screensaver, we enable the ability to require a password. We prevent sharing files in profiles. We also provide a server admins GPO, number 5 here, and the key element of this is that there's an AWS admin, an AWS delegated server admin called admin, as opposed to administrator. The default user for administering Managed AD is called admin, and we add that AWS privileged user to built-in administrators so that your domain /admin can also perform the functions that would be performed by built-in administrators. And lastly, the time policy GPO, we give you the ability to choose to use either NTP servers or the time that's on the domain controller that runs your FSMO roles and runs the FSMO master. If you can choose to use either an NTP server or the time on your FSMO master as the time for your entire domain. There's a total of 1,238 configurable settings in AWS provided GPOs. Now, the next security feature we provide for Managed AD is a feature called Private Link. And the point of Private Link is to establish private connectivity between your VPCs and Managed AD. So if you look at my diagram here, if you have an instance that's running, say, SharePoint on IP 10.0.0.5, and SharePoint wants to connect to, is joined to, and needs to connect to the AWS directory service, instead of pointing to the directory service through the public IP of the directory service, we allow you to use Private Link, which is our service to say, connect over a private IP address. And so we'll set up a private IP or private link will allow you to set up an interface endpoint. This number 2 is called an interface endpoint. And that interface endpoint will have a private IP address. And that IP address will be associated with AWS Directory Service in this case. It can also be associated with all the other services that support private link. And by doing that, SharePoint never has to use a public IP address to talk to the directory. It takes place fully over private networking. And so private link will allow you to access managed AD over private link. And it'll also allow you to share access to the directory service over private link. And what I mean by that is, once you've enabled private link, then you can share your directory with hundreds of VPCs in the same region, or even VPCs in different AWS regions. And when you've enabled private link, you can enable all access to all your domain controllers, all your managed domain controllers to take place over this private networking private link service. Now, I mentioned, and we recommend that you perform log forwarding to consolidate security logs from both Active Directory and the directory service into CloudWatch. And you do that by clicking on the button that you see on the screen here. And this will provide log forwarding of domain controller security event logs to CloudWatch logs. Once you've done that, it's also easy to send CloudWatch logs to third-party SIEM systems like Splunk, Sumo Logic, and many others. And the benefit of doing that is it gives you a single source of all security log events to enable anomaly detection, pattern recognition, to look for security events that are tied to security exploits, and to perform security event correlation to try to determine, to sort of do some detection of, is there a chance that security events all add up to my environment has been exploited. Okay, so let's turn to the next topic in our agenda, which is administering EC2 instances securely. And the idea here is that we want to help customers get away from RDP over port 3389 and enable you to manage and administer EC2 instances in a secure fashion. And so I don't need to tell anybody who's watching that just like there have been lots of attacks and vulnerabilities and exploits around Active Directory, there have been also many attacks and exploits that target the remote desktop protocol, the RDP protocol. And I've listed a couple of them here, the botnet malware and stalkerware, and so there are lots of these. And so how can we lock down, or how can we provide more secure access to EC2 instances that are running on AWS? The answer is through one of the features of AWS Systems Manager called Session Manager. And so I've listed, just for the sake of completeness, the different features and the different capabilities of Systems Manager on the slide here. And I mentioned earlier that we have, for example, the run command if you want to run an SSM document, or if you want to run a command to basically perform any function on one or an entire fleet of instances. In this case, I'm going to talk about a different feature of Systems Manager called Session Manager. And Session Manager provides secure and auditable privileged access to your compute nodes. And so what Session Manager does is it allows you to provide instance remoting into any of your Windows or your Linux instances through VPC endpoints and private IPs. And so the first point here is you don't need to set up bastion hosts. You don't need, it's a best practice not to set up public IPs within Windows Server applications like my example of SharePoint. Everything can remain with private IP addresses, and we can remote into using a VPC endpoint technology. We can allow Session Manager to give you access to any of your instances, even if they're in private subnets, and access your instances through private IPs. You don't need a bastion host. You don't need to set up inbound firewall exceptions. You're accessing your instance through the agent through the systems manager agent that runs on EC2 Windows instances. You can also control who has access to be able to remote into an instance through identity and access manager policy. So typically you would take a group called IT admins or remote admins, and you would identify those users. You would create an IAM user group or an IAM user with the permissions to access instances, to remote into instances. And by the way, most of my customers will say, we're not going to control access directly at the IAM level. We're going to assign a group of AWS directory users, AWS managed AD users, and an AWS managed AD user will have federated access to these instances through an IAM role. And all of my management will take place at the AD level, not at the IAM user or IAM group level. So IAM allows you to provide fine-grained, least privilege access, and you can assign the users who have access to that IAM policy through Active Directory. And when you do that, and when you use this feature called Session Manager, you can remote into your instances like you see on the screen here, and all activity, including everything that's typed in that session, is logged to CloudWatch, S3, and CloudTrail. And so Session Manager is a really secure way to access your compute nodes without bastion hosts, without opening up public IP addresses, without even using RDP. So let's take a look at Session Manager in action. Within the AWS Management Console, I can type SSM to navigate to the Systems Manager service. And from there, I can select Session Manager in the left frame. And this will take me to a window that allows me to start a session or see existing sessions that I have open. And when I select Start a Session, I can then select any EC2 instance that I have running in that particular region. So I'm going to start a session on my instance called Stig2. And that brings me to a Windows PowerShell session for that instance. And at this point, I'm on the instance, and I can enter any command that I want to, or any PowerShell command to retrieve information. So systeminfo tells me, for example, that I'm on an EC2 instance running a T3 2XL with 32 gigabytes of RAM and 32 hotfixes installed. And if I were interested in knowing, for example, what are the agents that are located on this system, I can just type in get process minus name of Splat agent. And that tells me I've got a CloudWatch agent, an SSM agent, and a WinSudoTerminal agent. Okay, and so that's actually all there is to Systems Manager, Session Manager. So I hope you see how easy it is for me to remote into an AWS EC2 instance using Session Manager. And with that, with those 4 topics, we have a lot of customers who are interested in securing their infrastructure according to compliance programs and compliance baselines. And so for that topic, I'd like to hand things over to my co-presenter, Sean. Sean?
Thanks, Bill. As you saw in Bill's presentation, he talked about Windows hardening and imaging, using AWS Directory Service Managed AD, and administering an environment securely. AWS has seen an increase in commercial customers starting to inquire about many different compliance programs as they start to interact with various government entities, financial industries, healthcare, and other customers with regulated workloads. Not only do you need to build a secure environment, you need to validate that it meets certain requirements and maintain that security throughout its entire lifecycle. If you are not a public sector customer and familiar with government compliance programs, then this next part may sound a bit like alphabet soup to you. AWS GovCloud US is isolated AWS infrastructure and services for customers with strict regulatory and compliance requirements and sensitive data. AWS GovCloud US regions are built and operate to meet the same high security and compliance bar as all other AWS regions, while also addressing specific U.S. federal government requirements designed to protect controlled unclassified information, CUI, personally identifiable information, PII, export control data, and other forms of sensitive information. We also give you the tools and resources to accelerate your time to compliance. Our goal is to enable our customers with the highest bar in terms of regulations and compliance while using AWS and AWS GovCloud US. Now, the origins of GovCloud dates back to more than a decade ago when customers, particularly in the US public sector, became interested in understanding how they can migrate and architect workloads in the cloud to meet their highest levels of compliance and regulatory requirements. AWS needed a way to enable our customers to move sensitive data and regulated workloads to the cloud. To support these customers' unique requirements, we built the first AWS GovCloud US region in 2011, AWS GovCloud US West. We continued to see growing demand from these customers as more organizations moved more workloads to AWS GovCloud US, and we launched the second GovCloud US region in 2018, AWS GovCloud US East. Now, there are a few requirements you have to meet in order to gain access to AWS GovCloud US. Account holders must be a U.S. person, i.e. U.S. citizen or green card holder. The organization must be a U.S. entity and based on U.S. soil. Customers must not be barred from handling export control data. That's it. Those are the only requirements needed to start an AWS GovCloud US account. Now, fundamentally, GovCloud is all about compliance in the cloud. These compliance frameworks and regulations represent the core requirements GovCloud is built to address. Essentially, they govern the security policies and controls that agencies, contractors, and organizations in regulated industries are required to abide by to secure controlled unclassified information, CUI, and their regulated workloads. I will highlight a few of these, but if you have any questions about security and compliance, please reach out to Bill and I or to your account team, and we would be happy to sit down with you and dive deeper on this topic. So first up, we have the National Institute of Standards and Technology, or NIST, which establishes many of the underpinning of policies, practices, and procedures on this chart. NIST Special Publication 800-53 pertains to government systems and data and guides for how customers can abide by FISMA requirements. NIST Special Publication 800-171 is a subset of NIST 800-53 controls that pertains to non-government data centers and environments such as aerospace, defense, energy, etc. FedRAMP is a security and control framework from the federal government that allows customers to meet FISMA requirements in the cloud. AWS GovCloud US gives government customers and their partners the flexibility to architect secure cloud solutions that comply with FedRAMP Moderate and High Baseline, the Department of Defense DoD Cloud Computing Security Requirements Guides, SRG, for impact levels 2, 4, and 5, and other compliance regimes. Now, the compliant framework for federal and DoD workloads in AWS GovCloud US enables you to quickly deploy a secure, scalable, multi-account environment in AWS GovCloud US based on AWS best practices. This solution is architected to follow the Defense Information Systems Agency DISA Cloud Computing Security Requirements Guide, CCSRG, for hosting impact level 4 and 5 workloads in the cloud. Using the compliant framework, you can quickly deploy an architecture baseline that accommodates U.S. federal and Department of Defense requirements to rapidly achieve Authority to Operate, or ATO. In addition, this solution is architected to support and accelerate DoD Cybersecurity Maturity Model Certification, or CMMC, readiness. This solution will not by itself make you DoD CCSRG or CMMC compliant. It provides the foundational infrastructure from which additional complementary solutions can be integrated. To automate deployment, this solution uses AWS CloudFormation, and the templates are available to download and modify as you see fit. Now, the compliant framework also provides complementary functionality, including tenant account creation and management, identity and access management, data security and governance, core networking, and centralized logging. So based upon the AWS compliant framework and the security it provides, let's see some of its functionality in action. You have received an alert from Amazon CloudWatch that you have a new administrator user in the AWS IAM console that does not have multi-factor authentication or MFA set up. Amazon CloudWatch gives you complete visibility of your cloud resources and applications to collect metrics, monitor log files, set alarms, and automatically react to changes. Next, as we start to investigate, we can use AWS Security Hub to help us understand our overall security posture via a consolidated security score across all of our AWS accounts. We can automatically assess the security of our AWS accounts resources via the AWS Foundational Security Best Practices Standard and other compliance frameworks like the CIS benchmark. By drilling down into the finding in AWS Security Hub, we can then select Investigate on the example admin user. Once we select Investigate, we are navigated over to AWS Config. In AWS Config, we can see which rules are not in compliance, and we can even set a remediation action to auto-remediate this further. But before we do that, we should dive deeper to see who created this new user and if the new user has ever accessed the environment. Using AWS CloudTrail, we can check to see who created the new user account and if they have ever logged in with the new account. With AWS CloudTrail, you can track user activity and API usage to enable governance, compliance, and operational or risk auditing of your AWS account. And finally, we have a few options we can use to try and remediate this finding. We can try to auto-remediate this finding with AWS Config. We can reach out and ask the new administrator to log in and enable multi-factor authentication on their account. Or we can simply delete this user if it was not needed or was created in error. And so that wraps up a journey of using a few of the AWS services set up for you in the compliant framework for federal and DoD workload solution. This solution is available online, and there is a guide to walk you through its implementation. There is a link to it in the resources guide at the end of this presentation. There you have it. AWS provides a range of tools to secure Windows and the overall AWS platform, as well as deploying applications that are compliant with industry programs like FedRAMP and CMMC. Bill and I have covered security in relation to Windows hardening and image building, securing AWS directory service, and securely administering those instances. We also showed that securing your workload is just the first step as you start to get into compliance and ensuring workload security throughout its entire lifecycle. There are a few resources here that are available to you. If you have more questions, you can look at these links. These will help you. These are all things that we covered today, and these should help you along your journey. And so Bill and I would like to thank you for your time today. We hope you've enjoyed security and compliance with Windows and AWS GovCloud. We really appreciate it, and if you have any questions, feel free to reach out to us.